Next is physical significance of the wave function. The wave function, represented by xi, has no physical significance by itself. The only quantity having physical meaning is the square of its magnitude. It is called probability density. The probability density is represented by P. Okay, so probability density equation is magnitude xi square. It can also be written as xi star, where xi is the wave function of the particle, xi star is the complex conjugate of the wave function. So there is consider a region. Inside the region, particle is there. Particle, we don't know exact location of the particle. Particle, it may present inside the region. We don't know exact location. Okay, this particle is freely moving within the region. Okay, so there is to be find out the particle position using probability. The probability of finding a particle in a given volume of the space, the volume of the space is represented by dv. It can also be called write as dx, dy and dz is given by integral magnitude xi square dv is equal to 1. Okay, so here this equation, according to classical mechanics, the square of the magnitude of an electromagnetic wave is known as energy density. So here let us wave function associated with a particle, the square of the absolute value of the wave function xi. There is a square of the absolute value of the wave function xi, that is modulus xi square is the probability density of the particle. Consider a particle present in an unknown location within a region of space volume V as shown in the figure. Therefore the probability of finding the particle in a small element of volume dv is given by this equation. Any wave function satisfy this equation is called normalized wave equation. Okay, any wave function satisfy this equation is called normalized wave function. Okay. Next is probability density. So probability density, there is the probability equation is modulus integral modulus xi square dv is equal to 1. The total probability of finding a particle within the given entire space is always unity. That means it is equal to 1, where integral represents it extends overall space. The above equation can also be written as that is integral xi star dv is equal to 1. Any wave function satisfying this equation is called normalized wave equation. Okay, that is very important. This equation is, let's keep in your mind, this equation we can use in next derivation also. Next is some properties. Wave function have some properties that is given here. So it have 4 properties. So 4 property point is very important. This point explanation is not necessary for exam point of view. So first one, it says the wave function is a single valued wave function. Second is wave function is finite everywhere, and wave function and its first derivative with respect to the variable or continuous energy everywhere. For bound state, xi must vanish at infinity If xi is a complex function, then xi star must vanish at infinity. These four properties is wave function properties. It's enough.